I would like to give you some examples regarding falling object, and I want to give you more examples regarding height traveled by the particle, velocity, and the motion analysis of free fall. Okay, example. There's a falling object here, and it has initial velocity of 15 meters per second. Here, if velocity is 55 meters per second, what is the displaced or height traveled by this particle or by this falling object? So if you look at this problem, you don't have time quantity. If you don't have time quantity, you should apply this equation. Equation number 3. Therefore, here, v square minus v0 square equal to 2gh. V square is 55 square minus 15 square. That's v0 or initial velocity. 2 times 9.81. And h is unknown. Therefore, you can calculate height. So 55 square that's 3,000. 25 minus 225. That's 15 square equal to 19.62 h. Therefore, 19.62 h equal to 2,800. Therefore, h is gonna be 2,800 over 19.62. Therefore, height is 142.71 meters. Next example. There's a falling object here. It has initial velocity. V0 is 8 meters per second. Part A. Part A. At t equal to 2 seconds, What is the velocity of the falling object? What is v? Part B, at this moment, 2 seconds. What is the height traveled by falling object? What is h? Okay, part A. So if you need velocity and you have time value, of course, you should apply velocity equation here. Therefore, part A, apply this equation. V equal to gt plus V0. Plug in. V, we don't know. G or gravity, 9.81. E value, it is 2 seconds. And V0 is 8. So you can find the velocity of your particle. That's 27.62 meter per second. This is part A. Part B. What is height? So in order to calculate height, you should apply second equation, which is here. This one applied. H equal to half gt square plus V0 t. H is half, G is 9.81, T is 2 square plus V0 is 8, and T value, that's 2 seconds. You know, 2 square, that's 4. That's half times 9.81 times 4, and 8 times 2. Okay, here it is. The first part is here. The first part here. It is 19.62 plus the second part is 16. Therefore, you can find height. That's 35.62 meters. The unit of height is meters. This is second part. Sometimes you have this situation that you have falling object here and there is no initial velocity. In other words, you would like to release your object from the specific position. If you release your falling object, or if you drop your falling object at that moment, initial velocity is 0. Consequently, if you have this assumption in the problem, for example, it is dropped or it is released, it means initial velocity or V0 is 0. That's important and you have to memorize it. Therefore, next example is related to this assumption. Example. Here's a particle or falling object. It is released from a specific height. This is released. Part A. What is the velocity of your particle? after 5 seconds. What is V? Part B. At t equal to 5 seconds, what is height? Okay, if it is released, it means V0 should be 0. Therefore, you should apply it. Part A, you need to apply velocity equation. V equal to gt plus V0. Apply it. V, we don't know, G is 9.81 times 5. But V0, you should apply 0 here. So you can find velocity for your falling object. That's 49.05 meter per second. Part B, what is height? If you have time value, therefore apply height equation of gt square plus v0t. Therefore, h is half times 9.81. T value, it is 5 seconds square. You know v0 is 0, therefore the second part is 0. It is half times 9.81 times 5 squared, that's 25. Therefore, you can find height. It's going to be 122.63 meters. Here. So next example. There is a falling object here. It is released from a height of h. Look at this figure. From this height that we don't know, it is released. H. So if you release it, by a specific device, we can measure the velocity of your falling object before hitting the ground. I mean, this is ground here at the bottom. Okay. The velocity at the bottom, very close to the ground, it is V is here. V is 28.5 meter per second. I mean, before contact with the ground, it has this velocity, 28.5 meter per second. And we know that it is dropped from the initial position. What is height? Find h. Okay, what do you think regarding this problem? How can I answer this question? So I have final velocity at the bottom, and height is unknown, and we know it is dropped. It means initial velocity is 0. Therefore, I have two velocities, the initial velocities and the final velocity. Therefore, what is the equation that can be used here? Of course, equation of v square minus v0 square equal to 2gh. Equation number 3, or it is called time-independent quantity, time-independent equation, because it doesn't need the time value. Use it. And actually, over here, we don't have time value. So equation number 3 should be used here. V square minus V0 square equal to 2GH. What is V squared? This is final velocity. That's 28.5 square minus V0, you know that's 0, equal to 2 times 9.81 times h. So 28.5 square. That's 812.25 equal to 19.62 h. And from here, find h. That's 812.25 divided by 19.62. So find height for this problem. 41.4 meters. Next example. A falling object is dropped from a specific height and the height is unknown. Here, that's h. If we drop it, so it takes 3 seconds to reach the ground at the bottom. So therefore, it takes 3 seconds. If it takes 3 seconds, what is the height of this falling object at the beginning? What is h? Okay, what do you think? You need height and you have time quantity here. How can I find height here? Height is unknown. and your falling object is dropped, it means V0 or initial velocity should be 0 here. Of course, equation number 2 should be used. This one, because you have time quantity. For H, G T S squared plus V0 T. This half 9.81 T value 3S squared. And you know V0 is 0 here. It's half times 9.81. 3S squared, that's 9. Therefore, you can find height. It's 44.15 meters. Here. We want to talk about the gravity. You know, that's a kind of acceleration. And you know, acceleration has direction. As a matter of fact, acceleration has magnitude and direction. Therefore, what kind of quantity is it in physics? I'm talking about the kind of quantity. It can be either a scalar or vector. Okay, if acceleration has magnitude and direction, and every acceleration has magnitude and direction, definitely acceleration is a vector. And you have to learn it, which is essential. Acceleration has a magnitude and a direction. Therefore, it is a vector. Like velocity, if you remember, velocity has a magnitude and a direction. Therefore, that's a vector. Acceleration is a vector as well. Therefore, this is second example of vector. Consequently, gravity, which is an acceleration, that's a vector because it has magnitude and direction. Where is the direction of this acceleration? I mean, if you have falling object, if you release it, what do you think regarding the direction of the acceleration or direction of gravity? Of course, it is downward. It is pointing the Earth planet. It is downward. This is the direction. And what about the magnitude? Of course, magnitude is 9.81. 9.81 meter per second squared. That's a magnitude of gravity. And direction is always downward toward the Earth planet. And you have both of them. Therefore, it's a vector. Thank you.